Okay, dear students, so let us now talk about the topic C3, which is again like very difficult. I would say it's very lengthy, and I will not regard it as easy because the interference is in the SL part and the diffraction part is in the HL part. So this topic is divided into two, and both of them they're covering SL and HL, and still they're not easy. They're very confusing because the formulas are highly similar to each other, and students are getting confused in this. Let us see what is there in this topic now. For the topic C3, first of all, always believe that this topic can be divided into three parts. The first part is about the reflection of the light and the refraction of the light. Reflection is having a very small content, not at all, like it's not important at all. And about the refraction, there is the Snell's law, but the Snell's law is given in the data booklet here. You can clearly see N1 divided by N2. What is the situation? The situation is that there is an interface and the light is trying to enter into it. So light is bending because it is going into the denser medium, and this is the rarer medium. There is something known as refractive index. You must know what is a refractive index and how is the refractive index defined. Sorry, N is defined as C divided by V. C is the speed of light in air divided by V, the speed of light in the medium. So this angle is I, this angle is R. This is going to be dealt with the Snell's law. Now Snell's law is given in this formation already there, and only one thing was like remaining there. They have not given that. You can even add that because the frequency never changes when the light is entering from moving from one medium to another. Frequency is the only constant thing. If it is going into denser medium, the velocity reduces as well as the wavelength reduces. So I can just draw this. The wavelength here will be like thin here like this, and the wavelength here will be thicker. So you just imagine that if this is rarer, the wavelength is more, and if it is denser, the wavelength becomes lesser. Okay, so this is everything about the Snell's law. I've told you that the frequency is constant, and this is the bestest of the variations that are possible for the Snell's law that is already given there. By the way, that what I prefer is N1 into sine I is equal to N2 into sine R. So whatever you feel good, you can remember that part. So Snell's law is over, nothing more. Now, apart from that, the next part of the topic, it can be divided into two parts. Number one is interference, and number two is diffraction. Of course, there will be diffraction grating later, but majorly we can divide it into two parts. Now, coming to the interference, that is Young's double slit experiment. Now, the topic of Snell's law is utmost important for the SL students. Utmost important, like you cannot skip that if you're in SL, okay? Number two, if you're going for the interference, even interference is considered in the SL part. Just a moment, sorry for this. So it is considered in SL part. So the topic that I'm going to deal now, that is included in SL. So for the Young's double slit experiment, first of all, there is something called constructive interference. There's something called destructive interference. We gotta find the path difference. The formula is already given here. Let me repeat it. The path difference is written with d sine theta. This formula is not written in the data booklet. I have already given that formula here. But you have to remember it. It's a very important formula. You would be using it so many times. So this is important. Delta x is equal to d sine theta. Now for constructive interference, d sine theta will be equal to n lambda. And for destructive interference, like this is the path difference. Okay, remember that. The path difference, which is d sine theta, that is equal to n plus half lambda. Now, there is a big problem, and that big problem, I tell you now, that has not been addressed ever, and IB has asked questions specific to that, and students have been doing those errors consistently. Let me tell you what. Now in this, they have not written the value of n or the set in which the value of n is supposed to be. So the value of n is like it can, as it is already written, it is all the integer including 0 in both of the cases, in up and in down. But be very careful. This is the formula given in the data booklet. Of course, the students are interested in the formula which is given in the data booklet instead of what I have written. So let me explain what is there. in this and what is the discrepancy. Let us say there was one question, I have seen that in paper 2. If you're talking about the third bright fringe, you are going to use the formula for the bright fringes and n will be equal to 3. If you're talking about the third dark fringe, you will be using this formula which is given in the data booklet, but n value will be equal to 2. Now that's the discrepancy. Usually it goes, like without saying, and people think that, okay, if I'm talking about the third dark fringe, n will equal to 3, and if I'm talking about the third bright fringe, n will be equal to 3. What's the big deal in that? But no, this is correct only and only in the case of constructive interference. For destructive interference, you have to substitute the value 1 lesser than what is required. So for the fifth dark fringe, n value will be equal to 4. For the first dark fringe, n value will be equal to 0. Now this, I believe, is a very big error that has been done by IB, and I was expecting that in the new syllabus or in the new data booklet, because they have improved a lot, they will be improving on this formula also, but they have not. Okay, so even IB books are saying, talking about this formula, even the data booklet is using this formula. So it is better if you understand this formula here itself, and this is the discrepancy that you have to be using. Now what I have written here is, this is kind of like my formula, you can say, or the formula that I am using in Indian education system, or for that sake, this is the formula used in any other education system rather than the IB, not only in Indian. But okay, so what happens here is, you can just replace this plus with minus and this discrepancy vanishes. If you're using this formula n minus 1, then for the third dark fringe, n value will be equal to 3. Isn't it better? Without any confusion, without any doubt. But you got to use the negative sign for the destructive interference. Okay, for the fifth dark fringe, as I have already given you the example, n will be equal to 5 for my formula. For the formula given in IB, you will be using this, like the number one less than this. So be very careful. Please watch this video again. If you have some problem, rewind it and watch it again, rewind it and watch it again. Do some questions with both of these formulas to be perfectly clear, so that the error does not happen. Whether you use their formula or whether you use my formula, doesn't matter. You should be getting the correct answer. That is the objective. Okay, so this is done and this is done, and we have learned everything about the path differences here. So this is about the interference, but interference is not yet over. Listen to me. Apart from that, there is something that I want to use here. Now, what is happening? There is a relation, like let's say this is the pattern for the interference that you have produced. Like this, first bright, second, third, and you want to talk about the space, the fringe spacing. So this is given by this formula I've written here. Sn is equal to n lambda d by d. So let me tell you something more about the interference. This is included in the SL part, no doubt about it. So let me draw the pattern here. One quick thing, don't worry about, like I won't be taking much time. So this is the central bright fringe, then first bright, second bright, similarly first bright, second bright. The amplitude is not reducing here. Be very careful for the interference. And these are the slits here, like this. So I'm talking about, let's say, the second bright fringe. So this line I'm joining here, this is angle theta. The light is which is coming, it is actually going like this, and they are superposing each other at this point P. So this is the theta that I'm talking about. What is this theta? This theta is known as angular position. So angular position of the bright fringe or angular position of the dark fringe. This is the central, which is 0. This is first. Similarly, even this is first. This is also second. And they are known as first order. These are known as second order. Both of them taken together, they are known as like the second order maxima. But anyways, not going into details there. So this theta is going to give you the angular position of that very fringe. So if it is bright fringe, you could be using the path difference formula n lambda. If you're talking about the dark fringe here, you will be using the other formula. Now, I am just elaborating on the same thing, like d sine theta is equal to n lambda, like I'm talking about constructive interference. From here, sine theta is equal to n lambda by d, okay? And it can be approximated as theta is equal to n lambda by d. Now, if the question comes about what is the angular position, this is what you have to do, and the angle will be coming in radian. Now, moving next. If you want to find this distance, which I have written as y, or if your books are writing it as Sn also, so this theta is written with y divided by capital D. Now, don't ask me why is this possible, because there is this limit. You might have learned it in maths AHL. Limit sine theta is equal to tangent theta when theta is small. So I've taken tangent theta from this big triangle y divided by theta, and I have equated it with sine theta. If you are not able to understand, don't go into that much of the detail. Y is equal to y, n is equal to n lambda capital D divided by small d. This is another formula that you have to consider. So this was about the angular position, and this is literally about the centimeters, or like what is the distance of the bright fringe from the central bright fringe. So this will be that. So this is, I believe, everything about the interference, okay? And one more thing, like I wrote it that the path difference is d sine theta, so we can even draw that d sine theta here like this. This distance is taken as d sine theta, which is the path difference. This is a perpendicular dropped from this point. This is d sine theta. In many questions they're asking these kind of questions also, what is the path difference, and they provide you the gap of the slits. So accordingly, you have to find d sine theta. This theta is equal to this theta. Okay, I'm not again going into details. Of course, this is not 100% of the content, but I would be faster enough. So let us now move to the next thing. So this is all about the interference up to SL. Now let us go to the HL part now. So in the diffraction, you are having the same formulas, but only that you replace small d with the b. So, and the other thing is that for the diffraction, I think I have written everything on the next page. Yeah, here. So clearly for the interference, as I told you, that sine theta was written as n lambda by d. So you can just replace d by b, where b is the slit width and d is the slit gap, because in the interference there are two slits. In the diffraction there will be one slit, single slit. There can be multiple slits, but we're talking about the slit width. So you just substitute the value b here and it will give you theta. After that, like the y formulas, again you are just substituting the value of b there. But these formulas here for the y, you are using the constructive formulas from the interference, but this is for the dark fringe for diffraction. So let's say you're talking about the first dark fringe for the diffraction. This is the diffraction pattern that we have got. So this is first dark. So I'm going to use this formula. So y1 is equal to lambda capital D divided by b, and this is going to give me this. What is the thickness of the central bright fringe? It will be double of that, isn't it? You can write thickness is twice of lambda d by d. Nothing much to show here, up and down. And the others, they will be of the same thickness, lambda d by d. So the central bright fringe is clearly double thickness than other fringes. Okay, so this is about the thickness. And what is important is we are using the formula which is similar to the constructive interference formulas in the interference part that we did, but in the diffraction it is used for dark fringes. Now you might ask me, what about the bright fringe? If I want to find the bright fringe distance, what will I do? You have to find this distance for the dark fringe, then this distance from the dark fringe, and then you will find the midpoint of the two. That will give you the position of the bright fringe. This is how you have to find. There is no direct formula, and we are never ever getting into that. So you only find the dark fringes for the diffraction pattern. Bright fringe is the midpoint of the two dark fringe. Okay, so with this, I think diffraction is over. And now we are moving into diffraction grating, the one last part for the topic C3. See, diffraction grating, the word used here is diffraction, but it is using all the formulas of interference rather than the diffraction. So diffraction grating, there are many number of slits, first of all, like that, and you are concerned with the distance between the slits. Okay, this is B, by the way, but you're talking about the D. So if you talk about the D, you are going to use this formula: sine theta is equal to n lambda by D, and this will give you, like, it is going to create an interference pattern on the screen. Of course, it will be modulated with the diffraction. You could be getting something like this kind of a pattern I'm talking. Okay, and this is the interference pattern modulated with diffraction. This is the first bright fringe from my point of view. Okay, this is the first bright fringe. They're all primary. I'm not drawing the secondary, and I'm not going into details there. So there is too much detail. Secondaries, maximas, primary maximas. When does the secondary maxima is visible? When it is not? How many secondary maximas will be there? All those things will be there. They are not written in the data booklet. Too much of the things. So this, and by using this formula, you can find the position of the first bright. The intensity here is directly proportional to the square of the number of slits, number of secondary maxima. I'm just giving in this just for the sake of revision. If you're using n number of slits, it will be n minus 2 number of secondary maximas. And more is the number of slits, the secondary maxima keep on decreasing their intensities. So they keep on vanishing. Okay, anyways, so I can't teach each and everything in this video. So of course you have to either go for the lectures on C3, you have to become the member on the YouTube, or you can now become the member in my app also. By the way, you can go there and you can become the member there. You can watch videos. Okay, dear students, this is everything about the topic C3. In the next video, we would be talking about C4 and C5. All the best. Bye.